Jai Hind. Today we would be discussing what are the basic cryptographic concepts which are being used in the blockchain. In the last video, we have discussed what are the basic characteristics of the blockchain. So, the blockchain is a cryptographically linked system. So, traditionally, we were having that all these particular linked lists were connected or linked with each other through the memory addresses. But when we are using a blockchain, all these particular different nodes which we are considering into picture are being, they don't get connected with the memory addresses, but they are connected with each other by a technology which is called as hashing. Obviously, what does this particular hashing means? So, I should tell you, there are two types of hashing concept. One is we have two types of hash functions. One is symmetric hash function and another is asymmetric hash function. Okay. So, when we are doing cryptographically, we need two things. We can have a symmetric thing or we can have an asymmetric thing. Like in the last video, we have discussed, if I have a password as ABCD and I am sending this password with +3 reasoning, okay, so this text is called as the plain text. Okay, this plain text which was there in the password field is being sent in some hidden format or some change format, and this text which we are getting was EFGH, and this is called as ciphertext. Okay, so what we are doing it from a plain text, we are converting it to a ciphertext, and this process is called as encryption. This process is called as encryption. Okay. When we are going to the server side, this was from the sender side. On the receiver side or at server side, when we are taking EFGH, I have EFGH. Now I am doing -3. Okay. When we are doing -3, again I get a value of ABCD. Means from ciphertext, I am again getting the plain text. This is called as decryption. When encryption and decryption are done by the same key, when you're doing an encryption by +3 and decrypting is by -3, like we do in mathematical, when it is on the left hand side, when we are taking that particular value on the right hand side, it becomes +- or multiplication and division. So if you are doing it in the similar manner, then this is called as symmetric cryptographic functions. But when we are not using this particular normal concept, but we want that we have to use something different one, then it is called as asymmetric. In asymmetric functions, we are encrypting, obviously, we are changing the normal text, we are changing obviously the normal text to the ciphertext, or we are having that particular key. But in asymmetric, we are simultaneously generating a public key and a private key. As the name suggests, private is for me, public is for everybody. So when I'm sending a message, I generate two keys. One is the public key, another is the private key. So public key which I share with everybody, that is my email address. Okay, and the private key is the key which I keep to myself, that is the password of that particular address. So whenever we are sending that particular information from one location, or if I tell you that I have to do a transaction, I have to transfer 10,000 to my friend's account. So when I want to initiate that particular transaction, when I'm doing that particular transaction in a offline mode, what we do, I have a check. On that particular check, I sign that check and give it to the user. Obviously, my friend, that you can withdraw 10,000 from this particular check, and this is a valid check. What the bank person will do? Bank person will, when that my friend takes that particular check to the bank, they would see that if that particular signature is my signature or not. Okay, so that particular signature is being verified. If it is my signature, then they would withdraw the amount from my account and give it to my friend. Okay, so that signature which I am doing on that particular check is the private key. The signature which I am doing on the check is the private key. Okay, and the check which was that can act as a public key, because I can give that check when it is being signed. A blank check doesn't have any meaning unless and until that particular blank check is being signed by me. So that check can act as a public domain, but the signature acts as a private. So whenever we are generating this public and private key, obviously we are using this particular concept for authenticity. That particular bank, what that particular bank is doing, looking into that particular check, seeing the signature. If the signature is valid for me, then they would give the amount. So validity of that signature, authenticity of that signature is being checked. And the same authenticity when we are doing something in the digital form, how can we check that particular authenticity? By seeing if I am sending that particular data, encrypting the sending data, that is the plain text which I am sending is being encrypted using my private key, then that particular ciphertext can be sent. Okay, then that particular ciphertext using my public key can be converted to the plain text. Okay, so whenever I'm doing this public key, means I'm doing, in the terms of the cryptography, I'm doing a digital signature. That digital signature is being done by me. So that private key acts as a digital signature or authenticity of that particular function. Okay, so here what we are doing it, we are having that particular cryptographic technique which links one particular block to another particular block, and this technique is called as hashing. Again, we have not discussed hashing till now. We have discussed how we can encrypt by public key and private key while sending that particular text. So now what do we mean by hash? So what we are doing it, a hash is a function which we are using it in generating a fixed size data. That means even if I have, assume that I have a paragraph which has 4 to 5 lines. 5-line paragraph or a 3-word sentence. When I am doing a hash key generation, hash function generation, they would result in same number of bits, that is fixed size. Okay, so for this hash functions, to make that secure, what we do it, we have this main thing that the data which is being mapped results in a fixed size. So usually the hash function, hash is denoted by H. X is the message which we are using it. So X modulus n, where X and n both are integers, and modulus is obviously when we are dividing, the remainder gives that particular value. So we have that particular result, and that result is obviously whenever we are doing this. For example, if n is 9. No, sorry, n is 10. So whenever, whatever value you have, you can have 10,000, you can have crore of value, but the result of this, x modulus 10, would give you remainder 0 to 9 only. We have a fixed number. We have a fixed number in this particular range, that I have 0 to 9 only, which can be resultant because the mod is the remainder. So when we want a fixed size value, then we use a hash function. We don't want that whenever the message is more, the length of that particular hash key should be more. So we are using it. So it is one way that we can calculate this particular hash key, and these particular algorithms are usually they're different. It can be different. Obviously, whenever we are using it for our blockchain, we use the hash functions as SHA-256. SHA. S stands for Secure Hash Algorithm. 256 is 256 bits, or I can have 64 characters in that particular hash key. Obviously, when the function differs, when the value differs, the hash value also differs. Okay, so when I'm having hx1, the resultant is R1. When I have HX2, result would maybe or may not be, but it has to be different. Then only we can store those particular values. So we have this particular values where we can have this particular hash function, which basic advantage of this hash function is that we have a fixed size. Okay, and in that particular case, what we use basically in the blockchain is SHA-256, that is I have 256 bits or 64 characters which we would be using. So the hash linking helps in maintaining the integrity of the data. Obviously, consistency of the data should be same on each and every node. We don't want that there should be any discrepancy in that particular data. Each and every node should have the same local copy. All the consensus and replications are being helped so that we can have that particular integrity. Unless and until there is a consensus in all those particular nodes, we don't do that particular transaction successfully. So here that was a concept of cryptographically secure hash functions. So what next is, what do you mean by integrity? Obviously, integrity is the main thing, and integrity means once the data is agreed upon by all those the users or the parties which are taking part into the blockchain, then it should be freezed. We should have that particular data as immutable data, and it should become a tamper proof. No one should come and should claim, so that no one can come and tell that I have not done that particular transaction. When that particular user comes and tell that they have not done the transaction, then we can show them that this was the transaction which was initiated by you or done by you or updated by you. So once that particular, because in this particular blockchain I have anonymous users, I have to trust on this particular anonymous users. So trusting on that them becomes a bit maybe I get fed up that I don't want to trust those particular things. So I have to rely on those. So for relying on them, we have to have that particular data as tamper-proof data. So we have to keep the integrity of the data. So basically, the blockchain is not only the cryptocurrency, but you have other applications also. Because blockchain came into 2009, that was the first in the application of Bitcoin. But that Bitcoin was the cryptocurrency which was launched by Satoshi Ki. So we want that this particular concept, as if that particular person doesn't want it, that the central authority should come into picture. They should tamper anything, they should change anything, or we should rely on only one person for doing it. So similarly, we have this particular blockchain concept in some of the other application. Like when we are running a Windows operating system, you keep a log of all those particular events which are being done on that particular laptop, and that is called as the event log of the Windows. So, or in the database like Oracle, we are keeping a log file to track who has made the updation on the server, or what data was being updated by which valid user. So we have to keep a track. So we are doing that particular thing. If by chance the server, the system which I am running, the Windows get crashed. So what was the cause of this? When that particular system boot up again, then we can see the event log and see which application created a problem, and we can update that particular thing so that we don't get that particular crashing problem again and again. So we have to check which particular data. So we can do it by using the event log in the Windows operating system, or in the database system. When we want to see who has changed what a particular data, then it is being done by keeping the log files or the log trace files. In the companies, when we are doing it, usually we use a revision control system or the version control system, in which we are keeping a track of which particular user is taking out that particular file, making the changes, when checking out that particular file, so that we can keep a track which particular file, program file, or which particular file was being updated by which team member at what particular point of time, and what were the, when entering them back into the revision control system, they have to enter what changes they have done in that particular thing. So we have to check the log when see which particular history is being there. If some history is being missing and the data is being updated, we have to keep a track where that particular problem has arisen. So what are the basic uses? First, we have discussed we should have immutable. Once that particular block is being changed or that particular transaction is being done, then we have to freeze it. We cannot change that particular event in the ledger. So we should have immutable ledger of the events, and the transaction should have a timestamp. Like whenever you withdraw money from the bank, they give a slip. They tell you if you want that particular slip, you take out that slip, then it tells you from which ATM, which place ATM, what is the ID number of that particular ATM, your account number, and on what date, at what time you have taken out or you have withdrawn that particular amount. So they give that particular timestamp. We would be using this timestamp as a unique identity to see our records. So these particular data which we are keeping it, we have to have a immutable ledger of the events along with the transaction, and it should be time stamped. Along with, when we are keeping that particular log, we should not be able to update that particular log. So it should be tamper resistance. Why do we require tamper resistance? Like I'm working on my friend's laptop. I make some of the changes in that particular laptop, and I don't want that my friend should know it. I would go to Windows event log. Then I can delete those particular records where I have made those particular changes while that laptop was with me. Even I'm with his username, his or her username, but the time duration when it was there with me, approx 1 p.m. to 2 p.m., during that I made some changes, some system changes into his or her laptop, and I don't want that the user should, my friend should know it. So I would delete those particular records. When I delete those particular records, then my log becomes, it is not tamper resistant. It became changeable. So whenever he would see, he won't be able to recognize that I have made that particular changes because I have deleted that particular event trace. So the platform which we are having, it should be with the platform which is there, it should be we can create that particular transactions, we can transact, you can validate that particular transaction, and we have to create a log of all those particular transactions which are even not related with any currency. Always money doesn't come into picture, but like I'm telling you, I've made some changes into his or her laptop, and I don't want that user should know it. So in that particular case, currency is not involved, but I'm making some changes. So the person who you know well can make these particular changes. So what are the basic properties? You have to log into the data with digital signature. As we have discussed, the digital signature is basically my private key through which I am signing that particular document. So this becomes the private key of the sender. Private key of the sender, so that everybody knows that the person who has that particular thing would know that this has been signed by me, and then it should be immutable. Obviously, once written, we cannot make any changes. We have to see that it should preserve that particular, it should be secure. We should preserve that particular thing. Whenever, if you are able to make those particular changes, obviously we cannot have that particular trust on those particular anonymous users. So to make a trust on those particular anonymous users, we should have each and every user should send the data in that particular public ledger by signing it by its private key, and the block which is being created or the record which is being created should be immutable. We should have a privacy preserving, only the name should be there, not all the personal information should be there, and obviously so that we can trust each other. So maximum information should be hidden, and the information which is only required by the user should be given it. So we have to depend on the computing ecosystem. There are many different possibilities that it can impact, and we can have that particular transacting network which can temper that particular information. Transacting is sending and receiving, both comes into this. So we have to see that whenever we are doing it, we have to trust that particular environment in which we are doing it. If we cannot trust that particular environment, obviously the integrity of that particular result would vary, and you won't be able to process that particular data. We should know how we have to protect that particular data. And here comes the picture. We want each and every transaction should be secure, it should be distributed, and whenever we are doing it, we can authorize the person who is doing it. So for this comes the blockchain into picture. This is the characteristics which attract the people to come to the blockchain. Basically, when we are using this particular cryptographic function, these are computationally very hard algorithms which are being, so that it creates a tamper-proof data in that particular log, and we cannot delete those particular data. Once written, it's freeze. We cannot do it. That is the basic thing which creates a blockchain as a trusted process. One is distributed, or I should say decentralized. Each and every has an equal right. Then we have a tamper-proof data. For tamper-proof, we have a cryptographically, computationally hard algorithm which is being used. We have a transparency. Whatever is being done by the single user, it is get distributed to each and every person. It is immutable. We are preserving the privacy. We are looking into the security aspects. All these things make blockchain a trusted approach. So we require a blockchain, a trusted one. So we are keeping this as an immutable ledger. The blockchain is assigned so that we can have all those particular data into log, and nobody else means no malicious attack, no compromising of the data, or by mistake also nobody should delete anything. No transaction should be deleted, no transaction should be updated by chance also, by mistake also, or explicitly by a hacker or a malicious attacker or this. So in that particular case, we require all those logs to be immutable, and so we require a blockchain, which is obviously provided by the blockchain. No other database provides this particular immutable ledger. So tampering of data is virtually impossible in the blockchain, and it is possible practically. I cannot think of also that anybody can tamper that particular information. All the logs which are being there are the tamper resistant, and when this particular blockchain came into picture, it was because of this Bitcoin and the Ethereum. First was the Bitcoin, which used this particular blockchain. So Bitcoin was very famous in 2009. Then Ethereum came into picture in 2013. But later on, what technology we are using, what architecture we are using behind this Bitcoin and Ethereum, then blockchain came into picture. And that is the architecture design which we are using. So this was the first application, blockchain, which has obviously the idea was from our bank account. The whole idea was that why we should rely on a third or a centralized party or a bank server to do all those particular transactions. Why don't we cannot do it ourselves? Why we require a third party to have it, to keep a log, and we should see that what we are doing is correct. So in 2009, a person, Santoshi, came with a mindset that I don't want anybody. We can have anonymous users. I can make that particular block. It was the first block was made in 2009. That would be a tamper-proof block. Nobody would be able to change it by using cryptographically methods. And when we have this particular tamper-proofness and the security distributed aspects, obviously we don't want anything to be doing it. So the example which was there, because why Bitcoin, or I should say why blockchain came into picture is, obviously when we are doing some transactions in the bank, then multiple authorities come into picture. One is the customer, like me. So we have a customer is making a transaction. So I want to make a transaction from C1 to person P1. So while making this particular transaction, obviously bank would come into picture, and the bank server would come into picture, and the bank employee. So here we have one regulating authority. Why bank doesn't do any fraud? Because we have a regulating authority in India that is called as the RBI. So whenever there is some fraud in the bank, then bank has to report to RBI. So bank doesn't does anything wrong in that particular case. So whenever what transactions we are doing it, like we have seen the transactions in the blockchain also, when I'm writing a check or we are doing an online transaction, what we do it, we first of all thing what we do is, if I took the example, I have 50,000 in my account and I want to transfer 70,000 in my friend's account. So what we would be doing it, well, first thing what we will check, what the balance is greater than the transaction amount. If that is that the balance is greater then we would tell it as a valid transaction. If no, then it is an invalid transaction, and we can check this on the list of your online account. So where this particular information is being kept, obviously this is being kept at the bank. Bank is keeping that particular transaction data, but I don't want this third party person should keep my data. So we came from this particular normal decentralized system to a distributed system known architecture as a blockchain. So whenever we are doing it, when we are having a valid transaction, that would have an entry into the bank. If it is invalid transaction, that entry won't be there in the bank. So there can be bank frauds also, which is not possible in the blockchain. This is the basic thing because of which this blockchain can be understood. This is the first case study which I am taking it. So in the bank frauds, if I have written a check, see, if I have 10,000 written in it, and I have not written that particular on that particular check in the words, so anybody can make it 4,000 or 90,000 and withdraw the amount. Unless and until I look into my statement, I won't be able, or I get a message that person takes that particular amount. If I have a balance of 1 lakh, then 40,000 or 90,000 can be taken out. So if I have not written that again in the words, so this can be one of the fraud. And if there is some overwriting and the bank person is involved with the person who does this forgery, then my account will be get deducted by 90,000. This can be one thing. Or if there is a space between some and they enter one more, so this 10,000 becomes 1 lakh. So if this particular thing, obviously there should be two people involved. One, the person who needs to do a forgery, and the bank person who is inside it, so that he can see spaces are not proper and so on and so things. So we have to see that we don't want, unless and until we see the monthly statement, some fraud is being done into the bank. And when we go and tell the bank that the fraud has taken place, they don't consider that it is being done by them, because they tell you we are not doing it and we are not having that particular changes being done into it. So you have to agree what bank is telling you, that is non-repudiation. Obviously we have to agree on the amount which is being modified by the bank, that is the integrity. And finally we receive a monthly statement and look into it and then see if that particular transaction is being done or not. So whenever there is a bank fraud, we are 80% bank frauds cannot get detected, because in that particular case, internal person of the bank is being involved. I would let you know one of the case studies, that there was a 12 crore check which was debited from a medical institution. That check was checked under UV light. That check was original check. The signature was originally done by the trustee person, and 12 crore amount was deducted from that particular medical institution. They don't know who did it, how they did it, but bank fraud was being done in that particular case, and nobody was able to identify who did this particular thing. So that these are the reason we want to move from a central say authorized system to a decentralized system, or using a centralized system to a blockchain system, so that we can create a block which can be tamper proof, which can have a tamper proof resistant lock, and equally likely by each and every person. When the transaction would have been taken place in the blockchain, obviously each and every person should have validated this particular user and the amount which they have or not. So these particular types of frauds can be detected more easily in the blockchain as compared to the normal system which we are doing. So we are looking forward to overcome these particular frauds by using blockchain in our system, so that we can get a tamper-proof data and no frauds should take place in near future. We will take this case study in Unit 4 in more detail, and how we can overcome this by the blockchain. so that we can look into it, and we can see how these particular centralized system can be converted to the blockchain, so that we can get this particular data more secured for the customers which are using this particular bank transaction. Thank you for this video.